Here is something that will change how you look at your car forever. In the first 10 seconds after you turn that key, before your oil pressure even registers on the gauge, your engine is running completely dry. Metal grinding against metal thousands of times per minute, with nothing in between. And that 10-second window, that quiet little moment while you check your mirrors and buckle your seatbelt, is responsible for more engine wear than the next 5,000 miles of highway driving combined. The fix costs $3, it weighs 2 ounces, and it has been sitting on industrial supply shelves for over 80 years. Most people spend their entire driving life chasing the same cycle. Oil changes every 3,000 miles, synthetic upgrades at premium prices, engine flushes, stop leak additives, thicker oil in winter, thinner oil in summer, and still, somewhere between 80,000 and 150,000 miles, the ticking starts. The idle gets rough, the oil starts disappearing between changes, and eventually someone hands you an estimate that starts with a 4 and ends with a number that makes you feel slightly sick. An engine rebuild in the United States today runs anywhere from $4,000 to $9,000 depending on the shop and the vehicle. A replacement engine from a salvage yard is a gamble. A new vehicle means a new loan. Most people just pick one of those 3 options and move on, assuming that engine wear is simply what happens, that it is just the cost of driving. What if the wear itself was largely preventable, not through expensive synthetic blends or dealer-recommended service packages, but through a single compound that industrial mechanics, military engineers, and certain old-world farming communities have quietly relied on for generations, while the rest of the world paid for engine rebuilds they never needed? The compound is called molybdenum disulfide. Industrial mechanics simply call it moly. Chemists write it as Mo-S2. It is a naturally occurring mineral mined primarily in Colorado, Chile, and parts of China, and it looks like nothing special. A fine gray powder, almost graphite-like, that you could mistake for fireplace ash. A 2-ounce jar of the pure, technical-grade powder from a metalworking supply house costs roughly $3. That same compound, repackaged and blended into a branded Automotive bottle with chrome lettering and a bold claim on the label, sells for $25 to $40 at the parts counter. Same molecule, same effect. Very different price. The story of how moly went from obscure mineral to one of the most significant lubrication discoveries of the 20th century starts not in a laboratory, but in a military crisis. During the North Africa campaign of World War II, Allied tank engines were failing at catastrophic rates. The desert dust, ultrafine silica particles, was getting past air filters and scoring cylinder walls before the oil film could protect them. Engineers at Aberdeen Proving Ground were tasked with finding a solution fast, because you cannot fight a war with engines that seize in the heat. After testing dozens of compounds, they landed on molybdenum disulfide, mixed into the crankcase oil at a ratio of 1 part powder to 40 parts oil. The engine failures dropped dramatically. The documentation was filed under military technical bulletins that remained largely outside public circulation after the war ended. The soldiers came home. The knowledge stayed in the warehouse. Meanwhile, in 1971, the Japan Automobile Research Institute conducted an independent comparative study, testing moly against 47 other lubricant additives under controlled friction conditions. The results were published in their internal technical bulletin and, for reasons that remain somewhat unclear, were never widely translated or distributed in Western markets. What they found was striking. Molybdenum disulfide reduced friction in the boundary lubrication zone, that critical zone between metal surfaces during startup, by 68%. Wear on camshaft lobes dropped by 70%. Engines in the test showed measurable cylinder wear at the equivalent of 400,000 miles. That was less than what conventional oil-lubricated engines typically showed at 100,000. That research contributed directly to protocols adopted by high-mileage taxi fleets in Tokyo, where engines routinely reaching 700 to 900,000 kilometers on original internal components became a documented and repeatable outcome. Here's the science behind why it works, and I want you to really picture this. Inside your engine, every surface that moves against another surface depends on a continuous film of oil to prevent direct metal contact. That film is what keeps your camshaft lobes from grinding your lifters flat, what keeps your piston rings from scoring your cylinder walls, what keeps your crankshaft bearings from seizing on the journals. But that film only exists when the oil pump is running and oil pressure is built. On a cold start, that takes anywhere from 8 to 15 seconds. During those seconds, you have direct metal-to-metal contact at high speed. The Society of Automotive Engineers published research indicating that the majority of internal engine wear, across the full service life of the engine, occurs during exactly those startup seconds. Not during highway driving, not during hard acceleration. Those quiet seconds every single morning. Molybdenum disulfide does something that liquid oil fundamentally cannot do. It bonds chemically to metal surfaces. It does not float in the oil, waiting to be pumped somewhere useful. It plates directly onto steel, forming a layer approximately 1 molecule thick. Think of it like a coating of the slipperiest substance imaginable applied directly to every surface it touches. And because it is bonded to the metal rather than carried in the fluid, it stays in place even after the oil drains back into the pan overnight. So when you start the engine on a cold morning, the protection is already there. The moly layer is already between the moving parts before the first drop of oil reaches the top of the engine. Researchers at Oak Ridge National Laboratory, in work that earned an R&D 100 award in 2014, described molybdenum disulfide's coefficient of friction as approaching the theoretical minimum for any known solid lubricant. That is not marketing language. That is material science. The reason this information never made it to your oil change reminder sticker is less mysterious than it might seem, and worth understanding clearly. The automotive repair industry in the United States generates over $100 billion annually. Engine rebuilds and replacement powertrains represent a significant portion of that revenue. A compound that meaningfully extends engine life, that keeps an engine running cleanly past 300,000 miles, rather than requiring a rebuild at 150,000, is not a product the repair economy is structured to promote. This is not a conspiracy in any dramatic sense. It is simply a market reality. The companies that formulate motor oil have designed additive packages optimized for the average driver under average conditions and an average service interval. Those packages are genuinely good, but they were not designed with the goal of maximizing engine lifespan. They were designed to meet performance standards within a business model. Moly sits outside that model. It has always been available. It just was never advertised to you. Long-haul diesel mechanics, industrial equipment operators managing generators, and irrigation systems that run continuously for years. And certain agricultural communities that prioritize extreme machine longevity over equipment turnover have kept this knowledge in active use for decades. In those contexts, engines treated with moly at regular intervals routinely outlast untreated engines by significant margins. Not by 20 or 30%, but by multiples. The documentation exists in maintenance logs, in industrial technical manuals, in military records, and in peer-reviewed tribology research that simply never filtered down to the consumer level. If your vehicle already has significant miles on it, say 150,000, 200,000, or beyond, here is exactly how to apply this, and it is genuinely simple. Start with a full oil change. Fresh oil, new filter, whatever viscosity your owner's manual specifies. Well, if you are above 200,000 miles, going one grade thicker than the manufacturer's recommendation is reasonable, moving from a 5W30 to a 10W40, for example, to compensate for the slightly increased bearing clearances that come with wear. Once the fresh oil is in, measure out 2 ounces of pure molybdenum disulfide powder. Technical grade, the kind sold for industrial gear lubrication, not blended automotive additives with other chemicals mixed in. You want the raw powder, pour it directly into the oil fill opening. Replace the cap. Start the engine and let it idle. Not driving, just sitting in your driveway with the hood open for a full 15 minutes. That idle period is what distributes the moly particles through every oil gallery, every passage. Every surface inside the engine. The particles reach the camshaft lobes, the lifter bores, the rocker arms, the main and rod bearings, the piston wrist pins, the timing chain guides. And because a higher mileage engine has microscopic pits and worn areas in its metal surfaces, the moly does not just coat the good metal, it fills in the damage. It plates into the worn spots and partially restores the bearing surface geometry, one molecule at a time. A study published in the journal Lubricants in 2024 tested this protocol on a high-mileage pickup truck and documented a 61% reduction in oil consumption, a 19 psi improvement in compression on the weakest cylinder, and elimination of cold start lifter noise within 40 miles of driving. A few honest cautions before you go further, because at Hidden Fix Lab, we do not sell you something without telling you the full picture. Molybdenum disulfide is not compatible with all oil formulations. Specifically, if you are using an oil certified for wet clutch motorcycle applications or certain limited slip differentials, moly can reduce the friction those systems depend on to function correctly. Check your application before you proceed. Additionally, more is not better. 2 ounces per oil change is the established ratio for passenger vehicle crankcases in the 4 to 6 quart range. Doubling the dose does not double the protection. It can actually cause the powder to clump in the oil rather than plate smoothly onto surfaces. Use the measured amount. Finally, if your engine has a severe internal oil leak or is burning oil due to failed piston rings rather than just minor wear, moly will not reverse major mechanical damage. It is a maintenance and wear reduction tool, not a substitute for mechanical repair on an engine that is already critically compromised. Here is what this actually means for you in practical terms. You have probably spent your entire driving life being handed the same information from the same sources: the dealership service writer, the Quick Lube franchise, the oil company's marketing, and that information has always pointed you towards spending more money. More frequent changes, more expensive synthetics, more additives that gum up rather than protect. The knowledge that a $3 powder could be quietly sitting in a metalworking supply catalog, doing what $100 synthetic blends cannot quite accomplish during those critical startup seconds. That knowledge was always there. It just was not pointed at you. What you do with it now is your decision. But the next time you turn that key in the morning, you will know exactly what is happening inside that engine in the seconds before the oil pressure builds. And you will know that for $3, you could make sure those seconds never do the damage they were always quietly doing. That is not a small thing. That is every cold start, every morning, for the rest of the life of that engine. Knowledge does not expire, and it does not have a labor charge attached.